Alright guys, so on this video, we'll work on L'Hopital's rule. I know we're in derivative section. This actually has to do with derivatives. However, L'Hopital's rule is applied on limits. So, limit as it goes to a number. Remember how the first thing that we did was one we plugged in. Remember that? Okay, well when we plugged in and we got 0 over 0 or 0 on our denominator, we ended up using different rules. For instance, we try to factor, or we try to multiply both top and bottom by conjugate if it has square roots on it. And if that didn't work, we knew there was an asymptote at that point. However, this rule kind of helps us to determine that a little bit quicker. So if you either have, so when you plugged it in, so you actually have to do plug it in first. That's the first step of limits anyway. So we're basically going back to limits. When you first plug in the number, and you get 0 over 0, or if you get infinity over infinity, so either one of these, we can apply L'Hopital's rule if and only if this works. So if we have 0 over 0, if we get 0, 0, 0 on our limits, or infinity over infinity on our limits, we can apply L'Hopital's rule. Here's how L'Hopital's rule actually works. We're saying that limit of this, the limit of something over something, is going to equal to the limit of the derivative over that derivative. So here's an example. The first thing I'm going to do is I'm going to plug it in first. If I plug it in, okay, I'm going to get a 0 on the top and 0 on the bottom. Because that's 12 minus 14 plus 2 on the top. So that gets a 0 on the top and 0 on the bottom. And you have to write me that. So in this case, we can refer to our L'Hopital's rule. So on my free response portion, I do have to tell them that. So we're going to use L'Hopital's rule. L'Hopital's rule is, we're still taking the limit of this function, but we're saying the limit of this function is equivalent to the limit of the derivative of its function. So we're going to take the derivative of the top, which gives us 6x minus 7, all over the derivative of the bottom, which is just 1. And do you see how we kept the notation of limit? It's because we haven't taken the limit yet. We just applied the L'Hopital's rule and took the derivative. Now, once we've applied L'Hopital's rule, we're going to evaluate the limit. Remember the way that we evaluate the limit is to plug it in, so that's what we're going to do. So if you plug it in, we get 6 times 2 minus 7, which is 12, minus 7, which is 5. So we're saying the limit at 2, it would be 5. Of this function, it would be 5. Now, don't get this confused with the quotient rule. Remember the quotient rule? If I were to take the derivative of this, if I were to ask you, okay, so my function is this one, and if I were to ask you to find dy dx, if I were to say, find me the derivative of this thing, we do not take the derivative of the top and put it over the, we don't do the L'Hopital's rule, we do low d high minus high d low. So we'll do low d high, remember that, minus high d low all over low low. I understand this question is not asking for you to find the derivative of this function, but I'm giving you the distinctive difference between the L'Hopital's rule. Okay, so there's a difference between L'Hopital's rule and there's a difference between that and quotient rule. So make sure you remember that. All right, we're going to do the rest of the examples on a separate video, but on this video, you need to remember that L'Hopital's rule, L'Hospital, L'Hopital's rule is applied on limits. Okay, and if and only if you get 0 over 0 or infinity over infinity, positive or negative, does not matter. Okay, that's when you do. So when you use this L'Hopital's rule, you're taking, so you're still doing the limit as x approaches some number. You're taking the derivative of the top and derivative of the bottom just separately. So that's L'Hopital's rule. Now, quotient rule. Remember quotient rule, low D high minus high D low? Over low low. Okay, when you're doing quotient rule, this is when you take the derivative. This has to do with how you're taking the derivative. This is one of the techniques of taking derivatives. And this, but y'all see how this could be a little confusing on both of these. Make sure you know the differences between those two, and that's it for this video.